RegO has prepared this training module to inform the professional installer or system designer on certain containers or applications where our products are utilized. For the more technical problems and theories, there are many texts and manuals concerning the subject that should be consulted. The information supplied in this module is not intended to conflict with federal, state, or local ordinances and regulations. These should be observed at all times.
Good morning. Good morning. On behalf of RegO Products, we would like to welcome you and thank you for taking time out of your busy schedules by joining us today. This is our second week of a three-part training series in May. Today we will cover container installation practices. My name is Sean Carr, the new Business Development Manager in the Northeast. We also have Ed Varney in the West, Paul Bolduck in the Midwest, and Jay Sells in the Southeast.
Our distributors for having you guys attend and facilitate you guys getting on today. So thank you out to our distributors and thank you guys for attending and joining us today. And so today we're going to talk about container installation planning. So what are we going to reference? We're going to reference NFPA 58 2020, and most of this information you guys are going to find today are going to be right in our service man's manual. Then also too, thanks to our Canadian and Latin American customers additionally too that are on today. For more focused training, please contact your distributors to help us accommodate. If there's something that you see in there where your distances are a little bit different, please comment in and let us know. And so what is the difference between 58 and 54? Just for you guys that are new to the industry, where does 58 end? Where does 54 begin? 58 is at the gate and 54 is under the floor. So all the way from your propane tank to from your first stage regulator to all the way to that second stage regulator, your 2 PSI service regulator to that outlet is going to be where NFPA 58 covers. Now inside in the house, what is that going to cover? That's going to be NFPA 54. And some real quick RegO trivia. Just wanted to give you guys some kind of RegO trivia. When did RegO start? RegO actually started in 1908, so we've got over 110 years of service. We've been around the most in the LP gas industry. Who were the founders of RegO? The founders were Charles Bastian and Louis Blessing, and it was originally known as the Bastian Blessing Company. So we talked about last week that RegO means regulator oxygen. This came from the Bastian Blessing Company. Then was one of the founders blind? Actually, Charles Bastian, before they made this Bastian Blessing Company, was fired from his job, and he actually joined forces with Louis Blessing and actually made the Bastian Blessing Company. So that was the start of RegO. It's a really cool and interesting story, and if anybody would like me to share it, please email me. Then what is our agenda today? So container installation planning. We're going to go over general guidelines, installation distance requirements, container selection, and then purging containers. Paul?
Let's talk about pressure tests and leak checks. Is there a difference? Yes, there is. Leak checks should be done immediately after the gas is turned on into a new system that has been initially restored after an interruption of service. The piping shall be checked for leakage per NFPA 58 and NFPA 54. Pressure tests should be done on new installations and when adding branches to an existing installation. Pressure tests should be done according to NFPA 54. Test pressure shall be no less than 1.5 times the proposed working pressure, but not less than 3 PSI. Test duration shall be a minimum of 10 minutes, but not required to exceed 24 hours. See NFP 54 2018 edition 8.14 for instructions. Does a leak check have to be done after a pressure test? Absolutely yes. Let's talk a little bit about cathodic protection. ASME containers installed underground, partially underground, or mounted shall incorporate provisions for cathodic protection per NFPA 58 5.2.1.11. Where installed, cathodic protections shall comply with 6.193, and 6.19, 3.1 all the way through 3.3. Cathodic protection systems installed in accordance with this code shall be monitored by testing. The results shall be documented, and conforming tests shall be described by one of the following. In our industry, we use copper sulfate half cell, which is number 1. We must produce a voltage of negative 0.85 volt or more. Other preferred methods would be with a KCI calomel half cell, and that requires a voltage of negative 0.78 volts, or a silver copper chloride half cell to produce, and would need to produce a negative 0.80, or any other method that's described in Appendix D. In our industry, the copper sulfate half cell, negative 0.85, is our rule of thumb. 6.19.3.2. Sacrificial anodes shall be tested in accordance with the following schedule. These dates are important. Upon installation of the cathodic protection system, unless prohibited by climatic conditions, in which case testing shall be done within 180 days after the installation. Number 2, for continued verification of the effectiveness of the system every 12 to 18 months after the initial test. Number 3, upon successful verification testing and in consideration of previous test results, periodic follow-up testing shall be performed at intervals not to exceed 36 months, so every 3 years. Systems failing a test shall be repaired as soon as practical, unless climatic conditions prohibit this action, in which case the repair shall be made not more than 180 days thereafter. And once again, that testing needs to be restarted as required in 6.193.2. Documentation, the most important part, documentation of those results shall be retained. Cody?
Thank you, Paul. And what Paul said right there is the main important thing. Make sure you guys are documenting everything. If you're going ahead doing a leak check and a pressure check, make sure you're documenting that and you're filling out your paperwork properly. Now, installation of containers and distance requirements. So we're going to start off with location of DOT cylinders. So what we have exchange cylinders. So you've got an exchange cylinder, and then we got one filled on site. So what is the difference? So filled on site is going to have a different distance requirement versus exchange on site. So you can see here for exchange on site, we've got 5 feet minimum from an intake vent opening, then also 5 feet from the ignition source. So that's going to be your 60 pounders or 100 pounders that you're going ahead. If you have an automatic changeover regulator, you're going to be swapping that tank out. Then again, too, you're going to see 3 feet minimum from a building opening. Now, how about for a DOT tank? So that's going to be your 150 pounders, 200 pounders, 300 pounders, or 420 pounders. That's going to be 10 feet from that ignition source, 10 feet from that intake, and then it's going to be 3 feet from that building opening. So a building opening could be a crawl space, it could be a window, it could be a door. Make sure you guys are putting those tanks 10 feet away. Then on your notes 1 and 2, so where is that distance from? It's 5 feet minimum between relief discharge and the external source of ignition. So your air conditioner, direct vent, or mechanical venting systems. And if the DOT cylinder is filled on site from a bulk truck, the filling connection and vent valve must be at least 10 feet away from the external source of ignition, direct vent, or mechanical intake. Now, what is the difference between a DOT cylinder? So DOT cylinder, you're going to see a recertification period on that. So you guys are going out there after 12 years, and you might recertify it for 5 years with your visual inspection if you have a RIN number. An ACME tank, what are you guys doing? Much besides just some upkeep on that tank, there is no sticker or RIN number to put on that tank. You guys are just going to do a visual inspection, make sure that tank is clear, make sure you have no issues with the valves and anything on that tank. DOT tanks, what are they designed for? They're designed for portable applications that can be transported with propane if done so according to code. So it's just got to go with code, the DOT regulations, and your local code. Then ASME tanks, what are they designed for? They're designed for stationary installations and not designed to be moved with when containing propane. Go ahead and talk to your company and your policies. Some of these tanks can be transported to and from the yard with some propane in there, but it has to be, if you're picking up a tank, it has to be directly back to your facility. Then PRV settings. So what is the difference between PRV settings between DOT and ASME? PRV setting is 375 for a DOT and 250 for ASME tank. So there's a bit of a different range. Then also too, looking at that DOT tank, what are you going to see? A DOT tank is going to have that data stamped into that tank. So you're going to go ahead and see a 420 water capacity tank. And then on a ASME tank, you're going to go ahead and see that actually is going to have a name plate with a 120 gallon water capacity tank. So 420 pound for DOT, 120 gallon for ASME. So DOT tank will always be in pounds. ASME tank will always be in gallons. So how about for ASME containers? What is the distance requirements? So we have 3 different sections. We have above ground, under 125 gallons, underground up to 2,000 gallons, then above ground 125 to 2,000 gallons. So again, too, you're going to see note 1, filling connection and fixed liquid gauges are points to be measured from. So regardless of its size, any ASME tank filled on site must be located at the filling connection and fixed liquid level gauge are at least 10 feet from your source of ignition, intake, and your building openings. And then for under 125 gallons, what we have for our distances are under 125 gallons. So we have 10 feet from that intake to the direct vent appliance. We have 10 feet from that window, air conditioner, your electric meter, your electrical outlet, your sources of ignition. And we have 5 feet minimum from your building openings. So crawl space opening and your window and your doors. Now, how about distance requirements for a property line? We don't have any distance requirements for under 125 gallon capacity for that property line. But how about 125 to 500 gallons? What do we have? So again, we're going to have that same 10 feet from your ignition source and your intakes and your windows and air conditioners. But how about for building openings? That's going to be still 10 feet. So it's got to be 10 feet off the building. It's going to be 10 feet away from any kind of building openings or doors. Then property line. So 125 to 500 gallons, that's going to be a 10-foot minimum from a property line. Now, how about if you go up to 2,000 gallons water capacity? What are your distances going to be? You're going to be 10 feet again from the ignition sources. So you're going to be 10 feet from your AC, your window units. Go ahead and be 10 feet away from your electrical outlets. Make sure you're away from all ignition sources. How about property line? Property line is going to be 25 feet away, and this is going to be 25 feet away from your building openings. Then, too, if you see note 2 here, note 2 is going to be maybe reduced to 10 feet for a single container of 1,200 gallon water capacity or less if it is located at least 25 feet from any other LP gas container of more than 125 gallon water capacity. So you've got a tank, you got putting 1,010 feet off of the building. That is fine. It's just got to be 25 feet from that tank that's above 125 gallon water capacity. Now, how about underground tanks? Underground tanks up to 2,000 gallons. They're going to be 10 feet from your ignition source or your direct vent intake to your direct vent appliance. Then you're going to have 10 feet from that building. Then you're going to have 10 feet from that property line. And also, too, if you read note 3, the minimum distances from underground tankers shall be measured from the relief valve and filling or liquid level vent connection at the container, except that no part of an underground container shall be less than 10 feet from a building or line of adjoining property line. So no part of that tank can be 10 feet from it. Then also, too, note 4, so underground tanks with vehicular traffic, tanks must be at least 2 feet below unless otherwise protected. So you guys are using other means to protect that tank. It has to be at least 2 feet below grade or you guys are going to go ahead and do other protection that protected against any physical damage. No, we said we using the question and answer chat box. If you guys want to submit your answers on this, what is wrong with this installation? So what we see here is, what do we need for ignition source? We need 10 feet. Now you're not going to get that 10 feet right here. You're not going to have the distances. So this tank actually has to be put back 10 feet away from this this appliance. And also too here, you can see this regulator is not going to be 5 feet away from that ignition source. This generator would be considered an ignition source. And also too, they might want to look at their piping practices. You can see they put excess piping into this. With all these turns and elbows, is all that piping going to be good for that generator? Now, how about this installation? Is there anything wrong with this installation? Do we have our 10 feet from this intake and from that direct vent appliance? I believe we do. It looks like we do. How about that electrical meter? Yes. So these tanks would be installed properly. And also too, looking here, your tanks are up and out of the dirt. So when you guys go ahead and set tanks, make sure the bottom of those tanks are not sitting any kind of grass, mulch, or anything. You don't want those tanks sitting on the ground. You don't want it to create an issue where you can go ahead and rust out that bottom of that container. So make sure all your tanks are sitting up and off the floor. You don't want them sitting on the ground. Then how about groups of tanks? So recently in NFPA 58 2020, this is new to us. So this is going to be group of 4 tanks or less than 125 gallons each may be installed beside buildings with at least 10 feet between the groups. So the separation between groups used to be 25 feet. So from now you can have 4 120-gallon tanks and with a 10 feet separation versus when you, in the prior version, it was 25 feet away. And now this also goes to your local authority have jurisdiction as well. Make sure you talk to them. Each state can be different. Each county can be different. So make sure you talk to them. Make sure they're aware of this and see what you guys are operating off of. It may be that they're not operating off of NFPA 58 2020. They may be operating off some prior versions. And also, too, does your local authority have jurisdiction to have its own code book or own ruling? Now, how about putting tanks underneath a deck? So are tanks acceptable underneath a deck or an overhang? Yes, they are. Tanks are permitted to be placed under an overhang provided that the area is open at least 50% of the sides. So as long as you get 50% free air movement around these containers, this is fine. So paragraph 6.4.4.1 provides guidance to NFPA 58 users who install cylinders in outdoor areas that are protected from the weather. It establishes that a minimum of 50% of the perimeter of an enclosure area must be open to the atmosphere for those tanks. So they do have that. Now, what happens if this was concealed and this was actually a patio area up here that they went ahead and sealed off and they put walls up and a structure? Could you put those tanks underneath there? No, you can't. So if they went ahead and using that, if this wasn't a deck, this was actually enclosed and it was actually considered part of the building, no, you can't put those tanks underneath that deck. Now, how about 120-gallon tank installation? So we talked about groups of 4 tanks. So yes, groups of 4 tanks can be installed in next to your building. Now, how about installation of horizontal above ground ASME containers? What's wrong with this installation? Well, we can see here, it looks like it's set on a combustible material. They had some blocks here. I guess they didn't want to use them, but on this installation, if I was there, I would go ahead and here take this wood material out of there and set them on some blocks. So horizontal ASME containers designed for permanent installation and stationary above ground service shall be placed on masonry or other non-combustible structural supports located on concrete or masonry foundations. So they want to make sure they go back to that installation, remove that decking board underneath that tank, and they're going ahead and setting that tank on blocks. Now, what's wrong with this installation? Are these correct? So does a wood pile need to be away from that installation? So does these wood pile need to be away from these 120-gallon DOT tanks? Does this oil tank need to be away from it? This 500-gallon tank? Is this considered an important building? So what do you guys think? Paul, can you elaborate on that?
Sure. Let's talk about some other things to think about when locating your propane tank on a piece of property. Think about wood piles. NFPA 58 6.5.3.3 states combustible material shall not accumulate or be stored within 10 feet of a container. Don't store your wood piles next to this vessel, or have your customer not to do that. NFPA 30 defines a tank as a stationary vessel that holds 60 gallons or more of a combustible or flammable liquid. This distance does not apply if the LP gas container is 125 gallons or less, and the tank that contains combustible or flammable liquid is 660 gallons or less. So this oil tank up against the home needs to be at least 20 feet, or the propane tank needs to be 20 feet away from that oil tank. Back to you, Cody.
Thank you, Paul. So as we asked before, so what was the distances for that against that wood pile? So both of those installations that we saw before, the 10 feet away for that wood pile, those 120-gallon tanks would not be acceptable. Also, too, that 500-gallon tank that was next to the oil tank, that would not be acceptable. So they're going to have to go back and return to that and make sure they move those tanks. So how about these installations? How many feet away should these tanks be away from this source of ignition? So what's going on here? We got 3 120-gallon tanks right next to your air conditioner. So I'm sure the air conditioning contractor probably went ahead and set this after these tanks were set. But what do we need? We need 10 feet away from this source of ignition, 10 feet away from your electrical outlet right here, this disconnect. So they're going to want to move those tanks. So you can see here, there is a new set of tanks here. So there's actually going to be 3 120-gallon tanks here. And these tanks were actually removed. So they did go ahead and they fixed this. Also, too, with that, as you guys run into this stuff, you can see we have multiple pictures here that these were shared from you guys. So if you guys have any installations where you did fix them, you see something wrong, please send us some pictures. We'd like to see what you're doing to make things better, what you're seeing to fix some of these installations that are wrong out there. Now, how about this tank? What's wrong with this tank? Well, you can see this is an older tank. Looks like they may want to do some replacement on there. Some of this paint is fading, the tank's starting to rust. I would bring that back to the shop and try to refurb it a little bit, replace the relief valves and everything in it. But you can see here, we don't have 10 feet away from that air conditioner. It's definitely not 10 feet away from that building. What's going on here? Is this a garden hose hooked up to this? Where's the regulator? Your regulator should be at least 5 feet from that container. And we talked about last week, you want to install that container right at that connection there. So you want to install it above the level of that service container, that vapor service valve. Now, how about 2 underground? So we have 2 underground 1,000-gallon tanks here. What do we need for separation? So underground 1,000-gallon tanks would need a 3-foot separation. So what's wrong here? You guys can see from this tank lid to this tank lid, we're at about 33 inches. So this is not going to be acceptable. So they're going to have to go ahead and do some unburying of these tanks and going ahead and move some of these tanks out or abandon these tanks if need be. But these are some of the things you want to watch out for. When you're doing gas checks and leak checks, safety checks, you're going ahead and even new customer installations that you guys have, make sure you're checking everything is up to code. You want to make sure that the contractor that buried these tanks did install them correctly and they're going to be the proper distances away. Paul?
Here is another thing to consider when properly selecting a container, is properly select the container for economics and physics. A 30,000-gallon tank supplying a 400,000 BTU per hour load would require 4.37 gallons per hour, which equals to 228 days of LP gas. That container would be too large. It'd be a waste of money. Too small of a container would give you vaporization problems. It would cost money in unnecessary trips to keep it full and may not vaporize enough gas at peak demands, creating a system problem. Cody?
Thank you, Paul. So vaporization. So you're going to want to consider your vaporization rate. So we're going to talk about a little further here how to do the actual calculations, but we actually do have some charts that we can share with you and provide you as well too. So this is a chart that we have developed, vaporization rate for 20% full for a 1,000-gallon tank and 500-gallon tanks. So you're going to figure out what you're going to fill that. So refill at rate, what is going to be? So here we're at 20%, but that's which consideration is going to be, is where is going to be the best percentage that you want to refill that tank. So you guys can see for a 500-gallon tank at negative 15 degrees, you're going to be much less than 100,000 BTUs. Now, as it goes up in temperature and you get to 20 degrees, you're well above 500,000 BTUs. Same thing with your 1,000-gallon tank. You're going to be slightly above 100,000 BTUs at negative 15, but at 20 degrees Fahrenheit, you're going to be around 950,000 BTUs. So if you're experiencing some colder temperatures and you got a customer that calls in and said, hey, this has been working all summer long, but the minute I got cold, it's not working. What's going on? Well, what are you going to check? You're going to want to check your vaporization rate. So it could be working all summer long. That's your vaporization rate, your tank fill, the ambient temperature. It's going to keep that BTUs up. But as the temperature drops and it gets lower, you're going to want to make sure that tank is properly sized. Now, what happens if that tank is not properly sized? Well, you want to either consider adding tanks or you're going to go ahead and consider adding a vaporizer. So if you guys are out there installing vaporizers, this is going to make up for that vaporization rate of that tank. And same thing as well. So what is the difference between the temperature ranges? So what are we showing you guys here? So you can see at your refill rates, as refill rates go up and the temperature goes up, you can see the difference. So at 40% for a 1,000-gallon tank, we're a little bit below 200,000 BTUs. Now, how about 0 degrees? We're slightly above 600,000. Then how about at 20 degrees? So we're right above 1.2 million BTUs. So there is a big difference. And then what are some of the factors too as well? So what are the factors you're going to consider when you're going ahead and sizing these tanks? How difficult is that to reach? Does it have a bad driveway? Are you going to get stuck in the snow there if you know it snowed a few days afterwards? Are they going to be adding additional appliances? Always ask. You want to make sure the tank is sized for additional appliances. Happens all the time when you go ahead and you get out to a customer that you had for years, and you're wondering why they're using so much propane. Well, what's going on? They added an appliance. They never told you. They didn't let you aware of that, so you weren't able to go out there and do your leak checks with that new system. And then again, too, just a comment back on container sizing. This is a nice picture. I'm sure you guys can see many things wrong here. So what's wrong here? Polyethylene pipe. Where does polyethylene pipe need to be? I'm not even sure if this is polyethylene pipe. That looks like it could be PEX. But polyethylene pipe, your yellow plastic you guys are running underground, that cannot be exposed. It's going to be the same thing as your vent piping. It needs to be UV resistant. That polyethylene piping is not going to be. Only your risers are. Now, container spacing. Do you have any container spacing for this installation? No. Then the regulator must be installed at the outlet of the manifold. So I believe this is actually hooked up to the vapor service valve. And then what connectors are they using? It looks like they're using PEX connectors. So I'm not sure if this is PEX or not, but it looks like they're using PEX connectors. Now, how about sizing? So we're going to start getting into how to do your vaporization rates, how to calculate it. So what are we going to do? So we got 3 steps here, A, B, and C. Determine the maximum BTU load A for the system. So what are we going to do? You're going to figure out what appliances you have on there and what future appliances are going to have on there. So you're going to add up your range, you're going to add up your boilers, you're going to add up your furnaces, and figure out what your total BTU load is. Then you're going to go ahead and you're going to figure out what your company policy is for what you're going to refill at. So what are you going to figure out for your degree days of what you want to fill that tank at? So you're going to fill it at 10%, 40, or 60. Do you have a tank monitor on there and you plan on getting it at 30, 20 to 30%? You're going to figure out those calculations. Then you're going to determine the coldest temperature that system will experience. So you always want to go ahead and determine, figure out that vaporization rate at the lowest temperature that you may experience. So where are these calculations? These calculations to be done are actually going to be in your service man's manual. So how are we going to figure it out? It's going to be D times L times K. D is going to equal the overall dimensions in inches of that tank. That's going to be your diameter. L is going to be the length, so your length of that tank. And your K is going to be your constant factor percent of liquid in that tank. So you guys can see here, you're going to do D times L times K, and that's going to equal your BTU an hour. Now, what does that equal to? What degrees? You can see here on this chart, it's going to be vaporization at 0 degrees. So that's going to be calculated at 0 degrees. Now, what happens if you want to do it at negative 15 degrees or plus 20 degrees Fahrenheit? You're going to take this calculation and you're going to multiply it. So you're going to multiply it by negative 15 degrees. If you have negative 15 degrees, you're going to multiply your BTUs by 0.25. You got plus 20, you're going to multiply it by 2. Then also, too, with your calculations here, what is your K factor? So with D times L times K, this is going to be your percentage. So your percentage is at 20%. Your D times L and your K is going to be 60 here. Now, if it's at 40%, you want to refill at 40%, your K is going to be 80. And then if you're refilling at 60, your K is going to be 100. So it's going to be D times L times 100. So we're going to go ahead and actually calculate one. So we're going to calculate a BTU load of 410,000 BTUs, and we're going to be refilling this tank at 20%. Then the lowest temperature of that we're going to experience is going to be 0 degrees. So a 1,000-gallon tank, we're going to be 41 by 192. So what do? We're going to take that 41, you're going to times it by 192, and you're going to times it by 60. So we have 20% refill rate. That's what we're looking for. And we're going to use that 60. So we're going to do 41 times 192 times 60. So that's going to equal 473,320 BTUs. So for 410,000 BTUs, will that tank work properly? Yes, absolutely. Now, what happens if we had one 500-gallon tank? One 500-gallon tank with that calculations equal to 264,000 BTUs. So they can't go ahead and install one 500-gallon tank. Could they install two 500-gallon tanks? Yes, but you'll be better off setting one tank. So one tank is going to be good for 473,320 BTUs. Now, how about if we have some vertical 120-gallon tanks? What would it take? So we're going to go ahead and do some calculations where a required BTU load is going to be 290,000 BTUs. And we're going to refill that at 20%. And our temperature is going to be negative 5 degrees Fahrenheit. So what are we going to do? Your vertical tank is going to be 54 times 30. So you're going to take that 54, you're going to times it by 30. And again, we're going to calculate to that 20% mark. So you're going to use that 60 for your K factor. So 54 times 30 times 60. So that is going to equal to 97,200 BTUs. So how many 120s will we be able to use? So how are we going to calculate that? So, and also too, that's going to be down to negative 5 degrees. So the next step is we're going to take your BTU load at 0 degrees and we're going to times it by 0.75 for this factor, the multiplication factor to get down to your temperature. So 97,200 BTUs times 0.75 is equal to 72,900 BTUs per tank. So that tank is going to be good for 72,900 BTUs at a 20% refill rate at negative 5 degrees. So if we divide that 290,000 BTU load that we're looking for by 72,900, how many we're going to get? We're going to get 3.97 120-gallon tanks. So we're going to need 4 tanks there. So we're going to need 4 120-gallon tanks there for that installation. Paul?
Remember to always size your tank appropriately and always consider prevailing air temperature. Prevailing air temperature is especially important in the northern portion of our country and Canada. Remember, this table is located on page 8 of our RegO LP Gas Serviceman's Manual. Since temperature changes affect vaporization, the factors on the right side of the table will show you the change in BTU per hour rate. Multiply the results obtained with the above formula by one of the following factors for the prevailing air temperature. At minus 15 degrees, your multiplier will be 0.25. At plus 15 degrees, your multiplier would be 1.75. Back to you, Cody.
Thank you, Paul. And again, for you guys, what is a 1,000-gallon tank good for at 20%? At negative 15 degrees, you're going to see it's only good for 118,000 BTUs. For 0 degrees, it's going to be good for 473,320 BTUs. Then at plus 15 degrees, we're going to be good for 828,000 BTUs. So there is a big difference when you're going down to the temperature. You can see these ranges are very high between the differences. They're almost 300 to 400,000 BTUs difference. So is temperature a variable? Temperature is a variable. So make sure you guys are sizing according to that temperatures. Then how about underground tanks? So what do you can consider for underground tanks? So sizing underground ASME tanks is slightly different than sizing above ground ASME tanks. That is because underground tanks are not exposed to ambient air temperatures and humidities. And the two deciding factors for sizing underground tanks are the effective demand of existing and anticipated future gas appliances. So again, like we did, we calculated our max BTU load of all our equipment. Then it's going to be actually to your maximum anticipated frost depth. So it's not going to be on your temperature. It's actually going to be on the frost depth of that installation. So what is going to be your frost depth that you're going to be experiencing? So what are the two different size tanks we have? So right here, we're showing you this chart is going to be 25% full, and your minimum tank pressure is going to be 10 psi. So you get a tank that's going to be at 25%. That's going to be your refill rate. Then you got your frost depth right here. Then it's going to be figuring at 500 or 1,000 gallon tank. It's going to be what that riser is on that tank. So you're going to have a 6-inch riser on that tank, or you're going to have a 24-inch. You're going to have a AGUG tank, or you're going to actually have an underground tank. So what are you going to do? So you're going to figure out your frost depth. So if your frost depth is 24, you can see for a 6-inch riser for a 500-gallon tank, it's good for 483,000 BTUs. Now for a 24-inch riser, it's going to be good for 505,000 BTUs. So the deeper that tank is, the more BTUs you have. Now how about 1,000? It's going to be 855,000 BTUs. And then with a 24-inch riser, it's going to be 912,000 BTUs. Now, what happens if you guys in an area where it's got some heavy ground, you can't go ahead and bury that tank all the way. What are you going to do? Can you mount an underground tank? Yes, you can. So mounted underground tanks are installed higher than a fully buried tank, and it's covered with fill soil, forming a raised mound above the soil level. This method of installation obviously is for your landscaping needs. If you guys can't bury that, you guys are hitting rock and ledge and you can't get all the way down, you're not going to be able to get that tank into the ground. So what are your considerations on this? Again, this is going to be the same chart as prior. We're going to be at 25% full with a minimum tank pressure of 10 psi. So again, you're going to take your same BTU load. You're going to figure out if you got the same, your BTU load is going to keep up to that capacity. So 6-inch riser, 24-inch riser. Let's say your frost depth at 30 inches. So for a 6-inch riser, 500-gallon tank, it's good for 269,000 BTUs. Then your 24-inch riser, it's going to be good for 406,000 BTUs. And for 1,000, 6-inch riser, 517,000 BTUs. Then 24-inch riser, 726,000 BTUs. And then now we're going to talk about purging containers. So what are some of the steps you need to do? Containers are delivered to the plant typically in bulk or picked up from your distributors. So whether you're getting a truck there in bulk settings, you have the yard to handle all these propane tanks in your yard, or you're going ahead and picking up tanks individually. These containers should be checked for the proper purge before installations. So you might get a tank that has purge on it, but let's see, a valve or something got cracked loose, somebody opened up a filler cap, it could lose its purge. You're going to always make sure you check that and make sure that purge is going to be on that tank. So what are the problems that can occur when that container is not properly purged? So excessive artificial pressure buildup can happen. You could have an air/gas vapor mixture to appliance. You could put some air/gas mixture to that appliance. You could have some slow filling containers, so you're going to have a higher pressure differential, so it's going to cause those tanks to fill a little bit slower. Then other containers can be affected. So you can go ahead and contaminate another container with that air. So prevent excess pressure buildup. So what's happening here? What are we doing? What's going on? So assume we released all the compressed air of a tank. So you got a new tank. You went ahead and found out it didn't have a vacuum on it. You released that compressed air out of that tank, that leftover residual air, and the temperature is at 100 degrees Fahrenheit. So at 100 degrees Fahrenheit, your vapor pressure is 196 psi. And then also too, because you didn't go ahead and purge that air out of that container, you're going to add 1 atmosphere of air to that tank. So you're adding 196 plus 14.5 psi to that tank, and that's going to give you a total working pressure of 211 psi. So even though that container is completely empty, once you add propane into it, it's still going to have 1 atmosphere. So it's still going to raise up to 14.5 psi. So you have to purge that tank. Paul?
Without proper purging, an air-gas vapor mixture can flow to the appliances, which can affect burner performance and efficiency, resulting in a blowing or lifting flame. Back to you, Cody.
Thank you, Paul. Yeah, so if you guys are seeing blowing or lifting flames on a new installation, there's some of the things you guys want to think about. What are some of the things you guys think simple? Did you guys purge that tank properly? What's going on? You go and have a new installation, you're adjusting the air shut, and you're like, what's going on here? Check to make sure that tank was there. Call your office, see if the yard guy purged that tank properly or not. Then what happens? Unpurged air results in flow-filling containers. So what's going on? What does that mean? So assume you did not release all the compressed air of a container. So that container had 50 psi of air left in that tank. Then again, we're going to be at 100 degrees Fahrenheit. You're going to take that 196, and you're going to be adding 50 psi to that container. 196 psi plus that 50 psi is going to be equal to 246 psi. So you're putting a high amount of working pressure into that container. Now, when you go ahead and fill in that tank, what does it operate? It operates off of differential pressure. So the more pressure you have, the pressure difference between your container filling the tank is going to be the faster fill rate. So you have 246 psi. It's going to put you on a much slower fill rate. It could cause some wear and tear to your pumps. Then unpurged air can transfer into other containers. So you're tying multiple cylinders together. You got a tank that is going to get tied into existing installation. You could also contaminate another tank with that air. Paul?
These 4 conditions will result if you perform the properly purged LP gas tank. That tank will be free of air and will result in these conditions. Proper operation of appliances. The container will fill faster. There will be a reduction in the pressure relief valve discharge, and will also eliminate transfer of air to other containers. Cody?
Thank you, Paul. So we're going to talk about some steps to take of how to purge a container. So what are you going to do? So what we have here, we have an unloading adapter on this filler valve. So you're going to go ahead and have your 3119A, 3120, or 3122 on that filler valve. And you're going to go ahead and use that as an unloading adapter. So you're going to use that to empty the air out of the tank. You're going to have a pressure gauge in your POL connection. So you're going to have that 0 to 30 psi pressure gauge in there just to check to see what you're putting that vapor to. Then you're going to attach your vapor line. So you're going to attach your vapor line into that vapor equalizing valve. And then you're going to use no more than 15 psi going into that tank. So step 2, so after you connected all your fittings, what are you going to do? You're going to go ahead and open up that unloading adapter. You're going to exhaust all that air. So if there's any air left in that tank, it's got any compressed air, you're going to release that. Release air, make sure it's completely free of any pressure. Step 3, what are you going to do? So the next step is you're going to add 15 psi of vapor pressure to that tank. So go ahead and open up your valve in that vapor equalizing hose and go ahead and put 15 psi into that tank. So why not use over 15 psi? So we talked about air. Air is equal to 1 atmosphere. That's going to eliminate all the air out of that tank. So anything more than that will just waste. So do not use over 15 psi. You're going to be wasting propane. Then how about purging with liquid? Why do we say purge with vapor? The reason why we say purge Vapor is because when you put liquid in a tank, it's going to flash, it's going to boil off into a vapor, and that could give some chances where you're going to leave leftover air pockets. So when you're going ahead and using vapor, that vapor is going to fill that space of that tank, where when you're using liquid, it may not. Purging with liquid could give you as little as 50% of air removed from that tank. Then also too, when a vacuum purge container too as well, can you go ahead and purge that tank on that first fill? What do you need to do? Make sure you're putting 15 psi. So you have to finish this process at the end of it and put 15 psi into that tank. That's vapor. Then step 4. So again, we're going to exhaust all the air of that tank. So at first we release the air mixture. Now you're going to be releasing your air and propane mixture out of that unloading adapter. So remove and exhaust all that air and propane mixture out of that tank. Next step, what are you going to do? You're going to repeat that steps. So you're going to repeat those steps at least 4 times. And 4 times is going to get you to the point where it's going to be around 6.25%, which is adequate. And then your last fill, you can go ahead and leave that at 15 psi. Paul?
Hey, thanks, Cody. Most manufacturers and reconditioners pre-purge their tanks, but in the event you have to do a purging, this chart will help you conduct that purging. Remember, it's on page 12 of our LP Gas Serviceman's Manual. After the first purging, there will be 50% of air and 50% of propane. After your 4th purge, 6.2% of air will be remaining and 93.75% of vapor, propane vapor. Remember, never use liquid. Experience indicates that a reduction of the residual air content to 6.25% is adequate. The resulting mixture will have a thermal value of about 2,400 BTUs. In this case, the serviceman can adjust the burners for a slightly richer product. Moreover, the slight volume of air will to some extent dissolve in the propane if the installation stands unused for a few days. Let's talk about how much product was consumed. If the instructions on the preceding page were carefully followed, the vapor was purged 5 times. A total of 670 cubic feet of vapor would have been used on a 1,000-gallon tank. In a 500-gallon tank, a total of 9.2 gallons of propane would have been used to purge that tank. Pre-purge containers. This is a process where air inside a container is reduced down to a level where it is the same as 4 purges with 15 psi LP gas vapor. A vacuum pump is used to reduce the vapor pressure from 1 atmosphere to negative 27 inches mercury. Never remove that shrink wrap material. And to verify purge, you can use a negative pressure gauge, a negative mercury pressure gauge, to verify that you have negative 27 inches of mercury. If you don't have that negative 27 inches of mercury, you should consider purging the tank 4 times. Cody?
Thank you, Paul. So what are some of the rules? So what are some of the steps that you should take before you go ahead and put these tanks out in the field, before you check them? What should you check on these tanks? So with so many new containers being refurbished with a vacuum purge, there's many confusion of what to do. So most of these tanks that you guys are getting are now going to be vacuum purged. There is a new process to most dealers. We suggest that there's 3 basic rules that should be followed. So what are these steps going to be? So rule 1, when you get a container, do not open any valves. Do not remove any caps, plugs, or any kind of closures or loosen them. If you do, it's going to lose that purge. So if you guys ever cracked open a filler valve cap, you're going to hear that pull a little bit. It's going to have that vacuum on there. So you're going to make sure you guys are not removing any of those caps. And that's also too as well, Paul talked about the shrink wrap. There's shrink wrap around it. Leave that shrink wrap on it until you guys are ready to purge that tank. So what happens if you go ahead and let's get that filler cap off? you go ahead and check it and there's no vacuum in there, you're going to treat it like a new unpurged container. So we talked about the steps to purge your tank. You're going to go through that same process. And again, it's going to be at least 4 times or problems may develop. So make sure you guys are doing that at least 4 times. That is on your company policies and your SOPs, so your standing operating procedures. Make sure you see what your standing operating procedures are. It's not going to harm you if you do any more than 4. Then how can you tell if the vacuum has been lost? So every tank, you guys should be adding methanol into it. So go ahead, when you go ahead and you put your pigtail in there and you try to suck that methanol into that service valve, that's when you're going to check. You're going to see if that vacuum is weak. Is it not pulling that all the way? Do you have some concerns? If you want to go ahead and hook that up and didn't suck the whole container of methanol in there, you probably lost your vacuum. Then also too, as Paul said, you can also confirm with the gauge. So if you got to get a vacuum gauge, you can go ahead and check for that negative 27 inches mercury. Then rule 2. So what is rule 2? So we talked about methanol before. So you're going to want to neutralize that moisture left over. So because these tanks are hydrostatically tested, you want to make sure that from your tank manufacturers, you want to make sure that we go ahead and we add methanol in that tank. That methanol is going to eliminate that water and any residuals left in that tank. And then, it will cause for no regulator freeze ups. You're not going to have any kind of issues with appliances or any maintenance. Then rule 3, you're going to connect a PO well connection to that vapor source valve. And you're going to pressure contain that container up to 15 psi. So when you get a vacuum pressure container, can you go ahead and put liquid right into that tank? No. Pressure that container with vapor pressure to 15 psi. Paul?
Let's talk a little bit about neutralizing moisture. Water in a container that does not have LP gas vapor may cause rust, which may affect the strength of the odorant added to the propane. Water in a container will be withdrawn with LP gas vapor, and at certain temperatures could freeze in the orifice of the regulator as the vapor is withdrawn from the container, possibly stopping gas flow through the regulator. This is what should be used. We explained this last week in our regulator class. Only use 99.85% anhydrous methanol alcohol. It's important to avoid substitutes. They will not work. The secret of the effectiveness of methanol over all other alcohols is its high affinity for water, a boiling point lower than all other alcohols, and most importantly, a boiling point lower than water. If it is necessary to neutralize moisture in an ASME vessel, make sure you use the correct amounts. The proper amounts of methanol is located in our chart in our RegO LP Gas Serviceman's Manual on page 9. Never exceed the recommended amount. Too much methanol can affect system performance. A 100-pound ICC cylinder requires 1/8 pint, whereas a 500-gallon tank requires 5 pints.
Thank you, Paul.
So what are the benefits? The benefits are you're going to reduce the formation of oxides inside the container. Regulator orifice freeze up potential is greatly reduced. Back to you, Cody.
Thanks, Cody. This is Jay Sells, the Southeast Business Development Manager. We want to thank you for joining us today and hope you'll be joining us for our part 3 of our 3-part training series next week.